Okay, sorry I had to do a part two, but I had a little bit of technical difficulty there. We are back. I had just mentioned at the end of part one there. I think I got cut off anyway, but um, these are different now down here because now we're given the y. When we calculated these up here, these two, we were given the x value. Okay, the hiker's weight. Now we're given the y value in both of these. Um, the um, the backpack weight. So we are going. I'm going to go ahead and do this one. I'm not sure if I said this already, but I'm going to go ahead and do this one together with you now, and then have you do the last one by yourselves, and then we'll check that one. Okay. So anyway, let's go back to this here. When we were given the x, we applied this equation right here because we had our r, we had our x, and therefore we could get our y. Now our equation is flipped. No longer are we looking at y equals r times x, but now we're looking at x equals y divided by r. Okay, so the value of x, which is what we're trying to figure out, is actually worked out by taking the value of y, which is the backpack weight, and then dividing it by our rate. Okay, this this equation being in a sense an inverse of that equation. So if we do go ahead and plug those numbers in, if we have 8 pounds 12 ounces as our y, 8 pounds 12 ounces, which is 12 over 16, which is also, we know, 3 over 4. So 8 3/4, okay, is simplified here. 8 3/4 over our rate, which we know to be 2 over 21, okay. Um, you know the drill by now. Turning this mixed number into a improper fraction, 32, that's 35 over 4. Okay, that's this over here, divided by 2 over 21, which we know we have a complex fraction again. Okay, now we're going to go ahead, when we do our division, we are just multiplying with the reciprocal. So then we have 35/4. Okay, always has to be this one. You can't be taking the reciprocal of your numerator here. It has to be your denominator. Okay, so you're multiplying by 21 over 2. Now there's no cross-canceling here because 35 and 2 have nothing in common. 24 and 4 have nothing in common outside of the number 1, of course. So if we go ahead and do that multiplication, there's 8 on the bottom, which is the easy one. And if I get my calculator handy here, I'll go ahead and punch that in. That is 35 times 21 equals 735. And then if I go ahead and do the division to finish it off, 735 divided by 8, I get 91 and 7/8 pounds. Okay, 91 and 7/8 pounds. Let's go ahead and plug that one in. 91 and 7/8 pounds, which actually, in this column, actually, we're looking at doing pounds and ounces. So let's just stay consistent with that. So it's 91, and then 7/8 is going to be 14 ounces. Okay, 7/8 because we have 7 over 8 equals what over 16? 14 over 16, so that's your equivalent. That's how you get your ounces in this right here, okay? And then we can go ahead and add these two up. It's not a big deal. What's that, 100 pounds, 10 ounces, which is 10 over 16, or what, 5 over 8. This would be 105/8 pounds, okay? So yes, again, just taking this this equation here that we used when we were given our x value, and flipping that around, because now we're using this because we're trying to solve now for x in this recent one. We were solving for y before. okay? And that's the answer we get right there. So you go ahead and do this one, do that last one by yourself, pause, come on back and check your answers with mine. Okay, welcome back. I hope you got these answers right here. When I applied my 10 pounds as my Y, I got the X value, or the hiker's weight, as 105 pounds, and then our total weight as 115 pounds. Okay, let's continue on with example 2. When a business buys a fast food franchise, it is buying the recipes used at every restaurant with the same name. For example, all Pizzeria Specialty House restaurants have different owners, but they must all use the same recipes for their pizza, sauce, bread, etc. And this is, very similar and very realistic example here. Places like Pizza Hut and Subway and McDonald's all have the same idea. The recipes, you need to be able to step into any of those restaurants in any city in the United States, or even around the world for that matter, and get the same thing, and it needs to taste the same. Okay, this idea of consistency is, it's almost a frightening thing, but very, very important to a franchise or to a fast food business these days. Okay, I'll continue on here. So you are now working at your local Pizzeria Specialty House restaurant, and listed below are the amounts of meat used on one Meat Lover's pizza. Okay, so this is one Meat Lover's pizza. All right. First question, not anything related to ratios necessarily, but what is the total amount of toppings used on a Meat Lover's pizza? I want you to go ahead, and you know what to do here. You need to add all of these up, and they're all unlike fractions, as you can see. Go ahead and take a few minutes and do that. Come on back and see if you got the same answer I did. Okay, well, I haven't written my answer down yet, but I wanted to do this a little bit together. But you can see what I did here. Hopefully you can see what I did, but I found a common denominator, and actually this would be the least common denominator, as 24. And hopefully, again, this is not something, in an ideal world, everyone out there, all of you guys would be so proficient with fractions right now, I wouldn't have to go over this every single lesson, but I will continue to do this until hopefully you have this down and just absolutely natural with it. Okay, I chose 24 because I noticed, well, what I usually do, and I say I have eighths, I have sixths, I have thirds, and I have fourths. Okay, so I need to find a multiple or a number that each one of those numbers can go into evenly. Okay, now I'm always going to start with this. I'm going to find the multiples of the largest number, the largest denominator, which is 8. Okay, if I start from there, I'm guaranteed to get to this least common denominator fastest. Okay, I start out with 8. Of course, 6 and 3 cannot go into 8 evenly. Therefore, it's not a multiple of those. The next multiple of 8 is 16. 16 doesn't work. It works for 4. Doesn't work for 3. It doesn't work for 6. 16's out. Oh, here we go. 24. 24 is divisible by all of 8, 6, by 3, and by 4. Okay, so 24ths is the magic denominator right here. Okay, and now again, knowing my fractions the way I do, and hopefully that you do, the way I can make 1/4 into 24ths is I can divide 24 divided by 4 is going to equal 6. So my numerator here is 6. Okay, and because I go 1 times 6 is 6, 4 times 6 is 24, okay? Because I know there are 6 24ths in 1/4. They are the same thing. They are equivalent, okay? So we're making equivalence there. If I do this with thirds, I could see right away that it's going to be 8 24ths, okay? So 24 divided by 3 equals 8. And again, this is good because I'm looking at one unit of each one of these. Okay, I'm looking at 1/4, 1/3, 1/6. Okay, a little bit different when you have a different number as your numerator. A 1/6 is going to yield me a is it'll yield me 4 24ths. 24 divided by 6 is 4 times 1 is 4. 1/8 is going to be 3 24ths. Again, same deal. 24 divided by 8 equals 3. 3 times 1 equals 3. And the same here. Okay, it's the same number, same eighth, 1/8. So we are saying that 1/4 equals 6 24ths. The same thing. 1/3 is the same thing as 8 24ths. 1/6 is the same as 4 24ths. 1/8 is the same as 3 24ths. And again, 1/8 is still the same as 3 24ths. Now I can add all of these up. Can't add these as they were before. Can't add all those, all different denominators. But now with all these common denominators, I can do that. So I have 24ths, so I know that's that. And then I just start adding my numerators. I have 6. 6 plus 8 is 14. Plus another 8 is 18. Plus 3 is 21. Plus another 3 is 24. So 24 24ths, which is the same as 1 cup. Okay, so adding all of those different types of meat together, all those different fractions of meat is 1 cup. So each one of these Meat Lovers pizzas, each single pizza has 1 cup of meat. So 1 cup of meat per pizza. Okay. Okay, so now continuing on in the problem here. The meat must be mixed using this ratio to ensure that customers will receive the same great tasting Meat Lovers pizza from every pizzeria, specialty house, restaurant nationwide. The table below shows 3 different orders for Meat Lovers pizza on Super Bowl Sunday. Using the amounts and total for one pizza given above, fill in every row and column of the table so the mixture tastes the same. So we're keeping these ratios the same. Okay, so we're going to need to look at this again here. So let's always remember now, each pizza, each Meat Lovers yummy delicious pizza, okay, has 1 cup of meat, and 1/4 of that cup is sausage, okay, is sausage. Let's start there and let's go ahead and look at this. So if we know that each pizza has 1/4 a cup of sausage in it, that's for 1 pizza. This is our per pizza, and this is right here is our rate, okay. Per pizza for sausage is 1/4. Okay, so each pizza has 1/4, and order 1 has a whole cup of sausage, okay, in it. All right. We then know that we have what have we multiplied our rate by, or our pizza by, to get order 1. Now if you look at it this way, you're looking down on the order this way. Okay, so you've got your sausage, pepperoni, bacon, ham, beef, then total cups down here. So if normally it's 1/4 of a cup of sausage for 1 pizza, then how many pizzas, or how many have we multiplied this by in order 1? How many pizzas are we talking about here? Okay, so if we look at y equals, and again I know this is probably pretty easy for some of you, but is r times x, okay, and our rate is 1/4, okay, and we have our 1 cup of sausage equals 1/4 times what number? okay, we would then go ahead and do our division. And actually, you can look at it pretty closely here. 1/4 times what number here is going to equal 1, and of course that's going to be 4 over 1. So we are looking at 4. We are going to use a multiplier of 4 pizzas. Okay. Therefore, if we use this multiplier of 4 in order 1, we would then all we would need to do then is look at everything else. So if one pizza took 1/3 cup of pepperoni, if we're using a multiplier of 4 times 1/3, that's going to equal 4/3. So now we have 4/3 cups, or 1 1/3. Maybe we'll just go ahead and do that. Let's go ahead and let's use mixed numbers here. 1 1/3 cups of pepperoni. Okay. Now bacon is normally 1/6 of a cup of bacon. If we multiply that by our multiplier of 4, we have 4/6, or as you can see, 4 over 6. We reduce that. We can simplify that to 2/3. 2/3 cups of bacon. Now let's look at ham. So ham was originally, or not originally, but for one pizza is 1/8. And if we did that and multiplied 1/8 by 4, we get 4 over 8, which is the same as 1/2, which we already have here. And beef, as we know, is the same as ham. It's also 1/8 per pizza, and that would be 1/2 as well. Okay. Now we can we can add all these up. If we're looking down again, we're looking down order 1. Okay. We're looking down. Let's just go ahead and combine a few things. We can combine these two. 1 1/3 plus 2/3 equals 2. So those together equal 2. And 1/2 together equal 1. Okay, so that would be 1, 2, 3, 4. So 4 total cups, which makes sense. Okay, we could have just used our multiplier right here of 4. Okay. Alrighty, so how about 2, order 2? You go ahead and give this one a whirl. Okay, and you'll notice that you have just one piece of information. In this one here, you have that you have 1 full cup of bacon. 1 full cup of bacon. Alrighty. Now, if you look at it, I just would want to ask you right away. In order 1, you notice that there were 2/3 cup of bacon. If there is a whole full cup of bacon in order 2, is the total cups going to go up, or is it going to go down? We're going to have more total cups in this pizza, in this order, or less. Okay, and hopefully you said more, because that is right, because 1 is more than 2/3. So therefore, all of your numbers here should be, I'm giving you just one hint here, should be more than they were in order 1. Okay, so go ahead, complete that. Complete 3 as well, and I'll come back and have the answers here for you. Okay, if you can remember, last time we had a similar situation where we were given our x as we were in this first here order. We're dealing with order 1. Now we're looking to solve for x. Okay, we're trying to find this this multiplier, what we're multiplying by, how many times we're multiplying by, and we're trying to actually get number of pizzas. You know, when we found this 4 over here, we actually found the number of pizzas, because it's easy, because each pizza was going to have 1 cup of meat total. All right. So we want to find out. So we have x. We have our y, which is 1. Okay. We have one cup of bacon, And then the rate for bacon, remember, was 1 over 6. Okay, it was 1, go back here, remember it was 1, not there, but 1/6, okay? All right, then if we did this equation-wise, again, this is pretty, I mean, I think some of you can get this, but if we did this equation-wise, we would go ahead and we would multiply 1 over 1, which is what 1 is, multiplied by 6 over 1, because we're dividing by 1/6, which means the reciprocal, and we would get 6 over 1, which is, of course, 6, okay? So now we know our multiplier, or our number of pizzas, is actually 6. We know this is going to be 6 down here. Okay, so everything needs to be multiplied by 6. All right, so if we did that, we know that, for example, sausage was 1/4, so 6/4, which is the same as 1 1/2. Pepperoni was 1/3. Is that 1/3? I made such a mess of this. 1/3. So 1/3 times 6 is 6/3, which is actually 2. 2 cups of pepperoni. 1 cup of bacon, that makes sense because 6 times, remember, 1/6 times 6 equals 1. Ham was 1/8. 1/8 times 6 is 6/8, which is the same as 3/4, and then we have 3/4 again. Okay. Now, of course, to check this, we could just do all the, we could add these fractions. And if we did do that, we could, let's see, what can we do? We could actually combine, so 3/4 and 3/4 is 6/4, which is actually 1 1/2. These two combine to be 1 1/2. 1 1/2 plus this 1 1/2 up here is 3. Okay, and then 3 plus another 2 plus another 1 just happens to be 6. Okay, so that worked out. All right, let me just clean this up a little bit. Okay. All right, so I said I was going to let you just go ahead and I was going to have you go do it and come back, and then we'd give all the answers. Of course, I didn't do that quite yet, but I'm going to do that right now. I'm going to plug in all the numbers for order 3. I'm going to come back and say, how'd you do? And I'm not going over it, okay? Because if you did get something wrong, you can go back and look at what I did prior, okay? So yeah, go ahead and take a few minutes now and finish up order 3. Okay, so here are the answers to order 3. Again, I just used what I knew, and that was I just chose the 3 because it was easy to work with. And so I knew, after I calculated, that if I knew each one pizza had a 1/3 of a cup of pepperoni, then 3 would have, then 9 would have 3 cups. So I knew that I had 9 total pizzas. And again, I went and applied that. I just multiplied all the rates, which for sausage was 1/4, pepperoni was 1/3. That was done already. Bacon was 1/6, ham was 1/8, and beef was 1/8. Okay, and I just multiplied those out by 9, all those by 9, because that was my multiplier here. And they came up with all these numbers, added them all up. They did equal 9, so I am happy, successful, smiley face. And I hope you are smiling as brightly as I. Okay, so here's our final exercise in lesson 13 before you move on to your problem sets and exit ticket. Again, another long lesson, and maybe you are spreading it out a little bit more, maybe going a little bit lighter on the problem set if you feel you've mastered this type of problem. Well, anyway, let me go ahead and read this exercise. The table below shows 6 different sized pans of the same recipe for macaroni and cheese. So if the recipe relating the ratio of ingredients stays the same, how might it be altered to account for the different sized pans? Okay, boy, sounds kind of hard to understand, but again, if the recipe relating to the ratio of ingredients stays the same. So this is the idea. This is what we need to find out first. We need to find out the rate. We're just going to say we want it to taste the same every time, no matter what size pan it's in. So we want to find that relationship. Okay, so they labeled it here noodles and cheese, so cups of each. So I just went ahead and labeled those X and Y because I like to figure out my rate as being a function of Y, Y as a function of X. So I'm going to do that to come up with my rate. I've already made another column here, and I've called it, I've labeled it R, which is cups of cheese per cups of noodles. Okay, cups of cheese per cups of noodles. So per cup of noodles. So for each, so per one, of course, be 1 cup of noodles. Okay, so I want to know how much cheese, or how many cups of cheese, or what fractional portion of cheese I need to put in for each cup of noodles I put in. Okay, now there's only one scenario, and that's this one right here, that actually gives us enough information to actually figure this out. We can figure out our rate by doing that one. So if I did Y divided by X, that would be 3/4 divided by 3 over 1. Okay, so that's this 3/4, which see the Y there, divided by 3, which is actually 3 over 1, because we're making a complex fraction, because we're trying to do this consistently the same, so we don't have any issues with figuring this out later. There's a little error on my screen. It's going reconnecting, and so I'm not sure if I'm even you're hearing me. So anyway, I'm going to keep trying here. I may lose you in a minute, but yeah, if we continue that, we know that we have 3. I'm not able to write, so I need to maybe wait. Okay, I'm not sure what happened there. Hopefully you're back and you can hear me. I might have been rambling there for a while, but again, so hopefully you got this much. I went ahead and I'm doing Y divided by X because I'm trying to find out my rate, and the only one scenario is this one here that allows me to do that. So then I have my Y 3/4 divided by my X, which is 3 over 1, or 3 is the same as 3 over 1. And if I go ahead and do that, I'm going to multiply by that reciprocal, okay, found in my my fraction here. So if I do that, that equals 3. Well, actually, I can just go ahead and cross cancel there. So that's 1/4. Okay. So my rate is 1/4, and what that rate means is 1/4 cup of cheese per cup of noodles. Okay. So here we go. 1/4, 1/4, 1/4, 1/4. This is always going to be my rate of cheese. Cups of cheese per 1 cup of noodles. Okay. All right, and then the way to, and then from there, I just go ahead and apply that rate into all these different scenarios and find my answer. So what I want to do here is I want to leave you to do that. All I'm going to do is, while I'm gone, I'm going to write the answers all in and have you compare those answers. If there's any discrepancy with your answer, go back, check it out. Maybe it was a simple mistake you made. Go back and look at this presentation, parts of it again, maybe to give you some clarity or clarification. And if you have questions further, just give me a call, send me an email. Okay? So go ahead and pause it now. Okay, so here are all the answers in green that I came up with. Just real briefly, I just go over them a little bit. I mean, if you're given, that there are 5 cups total, and you know that for every cup of noodles, there's going to be 1/4 cups of cheese. Okay, then you could figure out that. Just count cups. 1 cup, 1/4 of cheese. 2 cups, 1/2 cup of cheese. 3 cups, 3/4. 4 cups, 1 cup of cheese. 4 plus 1 equals 5, which we had already. And hence you get your 4 and your 1. Okay? This one, of course, we're just adding these two to get that. And if our rate is 1/4 cup of cheese per cup of noodles, if I know I have a 1/4 cup of cheese, I know I have 1 cup of noodles. Okay, and then of course just adding those to get the 1 and 1/4 there. Okay, if I have my 2/3 noodles, I'm going to apply my rate again, and I'll know that my y equals x times the r, so my y is going to equal 2/3 times 1/4, okay, and then I get 2/12, which is 1/6 right here, okay. And again, I don't know if this is too fast. Maybe some of you, again, this is going to take a long time sometimes. It's going to take quite a bit of time, but it's really well worth it. It can be a lot of fun. If this has taken you just forever and a day to get through, go easy on yourself with the problem sets, okay, if they don't look very dissimilar. But again, with the rest of them, it's the same idea, taking what you know, applying it with an equation, or another way, things that you know, for every one you at least know your rate, okay? 1/4 of a cup of cheese to 1 cup of noodles, okay? So as we move on, down here we have our lesson summary. Let's go ahead and just read this lesson summary together. Boy, this unit C, is quite a bear. There is, again, I think it's absolutely fun. I love it. Love doing all this stuff. And I hope you guys love it too, or learn to love it eventually. But we're going to take it a little bit, kind of slow down a little bit here to let this sink in. Stretch these lessons out if you need to. And please email me if you have any difficulty, something you need explained further. Okay? So here's our lesson summary. To find missing quantities in a ratio table, which is what we've been working with, all these ratio tables, where a total is given, determine the unit rate from the ratio of 2 given quantities and use it to find the missing quantities in each equivalent ratio. Okay, so what we needed to do, again, is we needed to be able to find either the ratio, okay, or the to find the ratio at some point using, and we usually do have 2 quantities that we can use to find the ratio, okay, and then from there we were able to fill in the rest of the table many times, okay. So as you can see, here's a problem set. Your first question here: students in 6 classes displayed below ate the same ratio of cheese pizza slices to pepperoni pizza slices. Complete the following table, which represents the number of slices of pizza students in each class ate. Okay, you have 6 different scenarios. Here they are: scenario 1, 2, 3, 4, 5, 6. Okay, and each you have actually here you have just one piece of information. Here's one where you can find your rate. So use that second scenario to get your rate and make another column if you need to. They're always going to be the same, but just so you remember here, this is going to be your rate. Okay, figure that one out first. Okay, so that's problem set. That's number 1. Here's number 2. Again, another similar problem, similar-ish problem. Another completing the table. What's the relationship there? Another one. If this turns out to be too much, you notice these are just the same. Just give it a miss. Okay, give one a miss. Maybe give yourself a break. Okay. All right. So go ahead and finish what you can. Exit ticket, which I'm not able to see up here on my screen. And good luck. See you in lesson 14.